Right. You might see some weird mungy stuff going on. It's been going on and off all morning. It's because, as you can probably appreciate, we're chucking sort of 1080p at some massive thing back there that then sort of munges, demunges, wraps it, whatever, and it ends up here. So it's not your normal projector. So I apologize if some things screw up here. I was asked to give a title for this. Now, the first thing to explain here is I have the privilege of being asked to do this presentation every year. This is my 8th. And as was mentioned by Simon, this isn't a VMware event. I don't by default get to do the keynote, but I get nicely asked back every year to do it. So I'm going to try and see if I can stay polite this time and get asked back again next year. Also, I'm essentially forming the first of a very long and entertaining warm-up act for Duncan Epping later. It's really what this is all about. And I'm fully aware of my position in that whole scheme of things. So what I wanted to do today was, I've done a whole bunch of other different things in previous years, and you'll recognize some of the slides today, especially the operating system for data center stuff, because I wanted to kind of do a, where are we going next? What's the next 20 years like? We're 20 years old this year at VMware. It's been one hell of a journey. I've been at VMware for 8 years. There's some people in this room who've been here a lot longer than that. Simon Richardson, for example, I think has been here for 27 years in a 20-year-old company. All I know is he has the email address of simon@vmware.com, so you know he's been here a long time. And it's been a fun journey, and I wanted to talk you through some of what we've done over the years very quickly. I'm not going to give you a whole history lesson, but then I want to talk to you about what we're doing next, because my job, obviously, as CTO, in the office of the CTO, is to think about what happens next and make sure that in 5 years' time we're even bigger than we are now. It's interesting facts about VMware now. Just in the 8 years I've joined them, when I joined we were just under 7,000 employees. We're now 24,000 employees. We currently have revenues in excess of $10 billion, hopefully this year if we get it right. And our market cap is $67 billion as of last night, which is bigger than Tesla, bigger than Daimler Chrysler, bigger than BMW. It's quite scary actually when you suddenly realize you work for a company that's that big. But it also puts a lot of pressure on you, because if you operate in the office of the CTO at VMware, a company that's ranked usually in the top 3 or 4 for most innovative companies worldwide across all industries, and you're in the department that's responsible for innovation, it's quite a thing to think about every day, is how do we stay on top of all this? And so actually, I want to talk a little about what innovation is for us. So we innovate by building and bridging across silos of innovation. And really that's what we do. We bridge across some amazing technology to bring it together into something bigger and better. And so our first act, what really made us famous, not Workstation, which was cool, and we all know, remember those days, or some of us do, was the fact that we bridged across multiple hardware vendors. You no longer had to choose who was going to provide the hardware for your data center. Virtualization freed you up to be across any hardware that you liked. Step one. And then we did some cool stuff like vMotion and things like that, allowing you to drag and drop machines in real time. Then there was the bring your own device era. I say was because I'd like to think the bring your own device era is kind of over. We don't talk about it anymore. It's much more in most places choose your own device, or, you know, look, you've got a load of devices, let's work out how we deliver stuff to it. And again, our end-user computing story has been all about bridging all those silos. No longer is it everyone has the same crappy laptop with Windows XP on it, with one of 2 different builds, whether it's the engineering or field build, right? We've all been there, I think, at some point in our careers, that everyone then takes and completely destroys, wipes and rebuilds themselves, and then makes it unmanageable for IT. We're now at the point where I don't care what you've got, Windows, Mac, Android, iOS, delivering you VDI, we're going to make sure you have access to the applications and data you need on any device. And that includes things like Chromebooks now as well, which we're uniquely able to do. Then, of course, the next was networking. And networking was an interesting one, because those of you who've worked in the world of data centers for a long time will know there's sort of 3 teams involved in running a data center and the infrastructure in there. You've got, if you ignore the M&E team, which just argue about electricity bills and power supplies and things, and cooling, and move into compute, networking, and storage, The compute and storage teams tend to get on now and again, right? I mean, the compute team's putting loads of fun new stuff in. The storage team is continually complaining about the fact they haven't got enough space to store the stuff that you're trying to create, and don't even talk to them about backups. And then there's the network team. And the network team have this amazing ability to pull out the security card at any point and tell you that you can't do what you want to do because of security, or because it's too hard, or because we can't do that yet, or because we haven't done the firmware upgrade until next cycle, which is in 14 months' time, or whatever. And when we're trying to build something special on top of that, trying to build a cloud, we needed to move beyond that. And so that's really, again, where we come in and we bridged across multiple hardware vendors and abstracted the network with NSX, or the virtual cloud network, as it's now called, if we include all the companies in that, if we include all the products in that family. So we've helped our customers build clouds. But then, sort of act 4 in this game is people try to migrate to the cloud, which people have realized is a little bit harder than you think. You basically have to rewrite most stuff if you want to migrate to the cloud. It's a whole, and that's not the big problem. A lot of people seem to think, oh, I can't move to the cloud because my application is going to have to change. The real problem in moving to the cloud is the change in operations. The change in the ops team you have to do, and the change in the way you build and run applications has to change fundamentally. It's not just about, I move VMs and have to maybe convert it from a VMware VM to an EC2 VM or whatever. That's not your problem. Your problem is operating in that world. And so with us, with the VMware Cloud Provider Partner Program, which has now hit over 4,000 worldwide, what we've done is we've enabled our customers to have the same environment on-premises that they have off-premises. So they have private cloud and public cloud, and we allow people to bridge that gap very easily. But that wasn't enough. The VMware Cloud Provider Program, despite you offering 4,000 choices, wasn't enough choices, apparently. I went to South Africa. I go to South Africa a couple of 2 or 3 times a year, if I can. And I'm down there this year, and I got interviewed by a journalist. And the journalist sort of said, oh, it's very exciting, because 2019 is the year when the cloud is coming to South Africa. And I said, well, what on earth are you on about? Oh, yeah, because Microsoft and Amazon say they're going to open down here. I said, I've got 49 clouds in South Africa. Which one of those don't you like? And so for our next act was a realization of what I'm going to go through today, of what's happening in applications. We're entering a multi-cloud era, and that's different to hybrid cloud, okay, in my definition of it. And hopefully as we go through, you'll understand how I mean hybrid cloud is different to multi-cloud. Hybrid cloud is running the same thing in different places, and I do stuff on-premises and off-premises. Multi-cloud is building an application that forever will use multiple different clouds or bits of clouds as part of its core operating architecture. Not that I run it in one place or the other. And so now we're looking at how we help our customers truly build multi-cloud applications. How do you spread across AWS, Azure, Google Cloud, IBM Cloud? So I'm going to talk in a little bit more detail about what we do in that space and what we're going to do in that space, without getting myself in any legal trouble with some people that might fire me. At the same time, our CEO, Pat Gelsinger, who honestly is, and I'm not saying this because I don't think it's even been recorded or whatever, I'll never see this, but he's an inspirational guy to work for. He has an amazing amount of energy. He's incredibly visionary. I mean, the challenge I've had is I've been a CTO for other companies before, and I've worked for CEOs who weren't CTOs, which is great because they don't know what you're meant to do. They kind of go, oh, yeah, you do CTO type things, I'll do CEO type things. Pat was the CTO of Intel, which is quite a big company, and worked there for 30 years, so he kind of understands the space and the tech space quite well. But he talks about these superpowers of tech. And for me, this is really important because we're in a really interesting time in our industry. If you go back 10, 15 years, or go back to the 90s when I was sort of building my career, we had fads, right? We had cool new tech that came out, but the cool new tech typically didn't come out that quickly. It was sort of a 2-3 year fad, and then you could move on to the next thing. We've got so many fads going on at the same time right now, it's mind-blowing. Okay. We've got so many different ways that the world is changing. First of all, we have cloud. which is giving people access to unimaginable scale, something that could never be done before. And this is no new story in the last 10 years, but that's really what cloud is about. It's about achieving a scale very quickly, very easily, from even just your phone, that you never could have thought of before. Put that together with mobile, which gives you unprecedented reach. You can put data, applications in the hands of people, power, computing power, if you connect it to the cloud, in the hands of people that is unimaginable 15 years ago. You know, I have to sometimes stop and make myself remember what it used to be like. You know, and now we wander around with a device that basically has the access to all human knowledge and connects us to all other humans on the planet, or a large percentage of them, in our hands, and we just take that for granted now. AI and ML. You can't be a CTO today without having a slide with AI and ML in it in your presentation. Otherwise, you're not a real CTO, apparently. That's what I was told. So AI and ML are in an interesting space. They're getting a lot of airtime. Why are they getting a lot of airtime? Because some really basic task-specific AIs have hit mainstream consumers. So things like Alexa, things like self-driving in cars like the Tesla. Consumers are now seeing the first iterations of really usable AI and machine learning in their hands that they can play with. But this is early days, really early days in the world of AI and ML. And it's an area that personally I spend a lot of time thinking about, talking about to people and trying to understand where and how the industry is going in this space. We have a long way to go in AI and ML, and I'll talk to you a little bit more later on as we get into some of the Magna stuff and some of the stuff that's going on in the future. Some of the challenges we've got that mean that, yeah, maybe it's not going to happen quite as quickly as you think, but it does mean that we're able to make real-time inference now in some very interesting places and is driving the growth of the edge, which I'll talk about later. And the edge is a really cool one. The edge is another area that I've been running projects on for over 3 years now internally at VMware. The edge is about the fact that technology is collecting, creating, and having to make decisions on data faster than networks and the cloud can cope with. So we have to start moving compute to be nearer to where that's needed. And that's happening in lots of different scenarios, which I'll talk about later on too. But if you get down to what is innovation and what is invention, it's very rare that people invent brand new things. What actually happens in innovation and invention is someone takes some existing things and puts them together in a way that's not been done before. That's when innovation becomes real. And in something like a space center, you're looking at that. You're looking at technologies that already existed in isolation. But you put those technologies together and suddenly you've got a space rocket that you didn't have before. And no one ever said, okay, I'm going to innovate and create a space rocket. A lot of the technologies that went into that space rocket weren't created for space rockets. Someone went, oh, that's really handy. And if we put that with that, that would work really well over here to do that. And that's what we see time and again with our customers. Our customers are taking cloud, mobile, AI, and edge, intertwining them in new and exciting ways, and that's where the innovation is going to happen. The innovation is going to happen when you as practitioners take these technologies and put them together in a new and inspiring way for your users, for your company. That's what I'd say is innovation in this room, and something that you can do in terms of innovation. So to help support that, we have the VMware vision. Now, the VMware vision has been the same for probably 5 or 6 years. We will help you run any application on any cloud and deliver it to any device. Now, are we not innovative because we've had the same vision for 5 or 6 years? Not at all. There's a couple of good things in that. One, it's a nice, broad, strategic vision. 2, we've continued to deliver on it, and we'll continue to deliver on that as we go forward. It's our guiding light as a vision for our customers. And we've continued to fill this map out. Those of you who've been watching this on a yearly basis will notice that Edge and IoT are now called out, sorry, Edge and Telco are now called out down the bottom in themselves. We used to have public and private. Now it's hybrid and public, because that's actually how we're seeing people evolve, how the cloud works, how things are changing. Cloud native's still there, but probably wasn't there 4 or 5 years ago because people with beards hadn't invented that term yet. But all these things are still happening for our customers. And the number of icons up the top continues to change and evolve as people start to put our technology on top of windmills and in ambulances and planes and things. So this slide was used at VMworld, and it actually means quite a lot to me because it talks to what's happening to our apps. We traditionally thought of applications, and app dev, and app architectures as something you did in data centers. It was how do you play with message buses, and how do you play with web servers, and how do you play with app servers, and Java, and things like that, and WebSphere, and WebLogic, and how do you hook them up to a database, and how do you get the right number of IOPS to do the thing that you want to do to make the thing happen with the thing, all in the data center. If you were adventurous, you built an application architecture that spanned 2 data centers, or maybe 3, and gave you some fault tolerance. That's not the applications of the future. The applications of the future are how do you bring together all the elements of your business and the users in it into one large network that creates the application, that involves data, mobile, cloud, all those things together. And that's what I want to talk to you about today. As applications explode out of the data center. That's the real challenge we're seeing in the industry. But first of all, I want to deal with something, which is kind of the elephant in the room here. Because we're here at the VMworld, the VMware user group, or the VM user group. If you want to confuse people or upset people, call VMworld VMware World. People at VMware Marketing really hate that. So at the VMware user group, we're infrastructure guys, right? I was going to say guys, by the way, I'm being across genders. We're infrastructure guys. We do infrastructure. But if you go to all the cool conferences right now, it's all about PaaS and serverless, right? Like, dude, stuff. I'm trying to get in with it. It's good. I've bought some slightly tighter jeans, but I'm still not rocking it. Still not quite got there yet. And then my beard is too long, apparently, which is unreal, really. My hair's also too grey. But all the cool, trendy people are talking about this, yeah? So why aren't we all talking about that? Well, let me tell you why we're not talking about that. We're not talking about that because it doesn't replace what we're doing. As we go forward, we're in the world where things are starting to split up, not get replaced. So if you go back in time, we're used to, as an industry, we're used to one technology replacing another. Yeah? Spinning disk replacing tape, which still hasn't happened for some people, but we're getting there. We're talking about MP3s replacing CDs. We're talking about, mainframes being replaced. If you work in a bank, yes, they were meant to be replaced by mini computers, which were then replaced, which, yep, they were meant to be replaced. Those RS-6000 systems by x86 and so on and so forth. That's not what's happening now. PaaS doesn't replace something else. What's actually happening is all application architectures will have their place going forwards. And what you'll find is as we go into this architecture for applications that we're developing, you'll find that you will have to have all of these elements. Now, you know the NIST model. Hopefully by now you know this NIST model. You know what IaaS is, you know what PaaS is, and you know what SaaS is, okay? Platform as a service, software as a service, infrastructure as a service. Now, what you're doing there is you're making trade-offs as you choose between those as the right place to run the component of your application. Higher up the stack is faster and easier to use, but potentially much more lock-in. Further down the stack, a bit slower to deploy, but operationally it's easier to have consistency across multiple different applications. Simple examples to explain those extremes for you. Very top, it's really easy to go and use Office 365. What's the alternative? Well, you could come down to the IaaS layer, find some open source bits and build yourself a mail server, and then find some other open source bits and roll out OpenOffice and then try and integrate it with some kind of web thing to make you do some sharing stuff. And it's like, do you know what? Nah, I'll just buy Office 365. But then when you want to move from Office 365 to something else, such as G Suite, it's not so simple, is it? Because you're intertwined in that application. So if you do say, I'm going to do SaaS for everything, for my whole business, I'm not going to do anything else, everything's going to be done in SaaS, that could be great, but you could find yourself dealing with 30, 40, 50, 60 different SaaS vendors. And then one day someone comes along and asks you for your GDPR compliance. And that's when you just basically polish your CV and run. Okay. Down the bottom end, you can't build everything, but there's some things that make a lot of sense to do down there. But of course, this is the technology world. So 3 wasn't enough. We wanted more things. Okay? Because ultimately, when you look at this, this is rent a VM, turn it with your code and rent a platform, and turn it with your apps and rent an app. Right? What we wanted was we wanted more granularity. So we introduced 2 more layers. We had containers as a service, which is turn up and rent part of a VM. Because like a whole VM, how extravagant, right? And then you have turn up and rent a platform as a service. And then functions as a service, which, what? Run all my app and pay for that? No, I just want to pay per line of code. Everything else is just wasteful and way too extravagant, okay? So now you've got rent a VM, rent part of a VM, rent a platform made of parts of a VM, run and just pay for a piece of code running on a platform made of parts of VM on top of a VM, or just turn up and use an app, which is built on top of that lot. Okay? And hopefully now you see that no one of those is the answer to all your company's problems. No one of those is the answer to all your organization's problems. You are going to have to somehow provide, manage, deploy, whatever, all of these. Have a strategy for all of these. Worse than that, it's not just 5 boxes. It's 10. Because you're going to have to decide which of these you're using on-premises and off-premises. And this is realistic. I'm not making this stuff up. I mean, my job is making stuff up, but I didn't make this stuff up. Okay? You're going to have to understand how all these work, understand how they all interact. And our job at VMware is to make that as simple as possible for you. And our job as part of the Dell Technologies family is to make that job as simple as possible for you. So let me give you an example from a customer of what they're doing today. I have a customer, they're a large automotive manufacturer in Germany. You know, they're rapidly going out of business, like all the German car manufacturers, but hey. At least their CEO's not in jail. Now, they're running functions as a service, which is on gateways in the factory to monitor the stock levels on stuff that's happening in the factory, both the cars themselves as they go through the factory and the supply chain that provides the parts to those cars. So they know how many widgets they've got, they know how many widgets is happening, how fast the cars are moving, all that kind of stuff. So they have functions as a service running there that's just firing up a piece of code now and again to read from a sensor. Maybe it's once a minute, maybe it's once every 30 minutes, once an hour, depending on what they want to do. That then writes down to a SQL database on premises. So the SQL database is on premises IaaS. Okay? Don't let anyone try and tell you running a database is platform as a service. Really. Okay? So running the SQL database down there in the IaaS platform. If you're running SQL in containers, we need to have a serious chat outside. Okay? So that's 2 of these already, both on premises. What they then do is they then run something they wrote in containers in microservices, which sits there and looks at that SQL database and a bunch of other SQL databases, all collecting from different places, and then dumps a sort of subset of that out to Amazon S3, which is, again, infrastructure as a service in a way, I suppose, if you want to call it that, out in Amazon AWS. They then use Cloud Foundry, which is running on Google. I'm not making this up, by the way. They're running Cloud Foundry, which is running on GCP, Google Compute Platform, so that's off-premises platform as a service, to then look at that S3 and then provide live dashboards as an application, software as a service, to their management so they can see on their phones and their iPads and all the other kind of stuff, what's going on in real time. In addition to that, because it's now permissioned in S3, they can sub-permission it, and they've got subsets of what they've got on premises. They now allow external providers, their suppliers of widgets, to connect into that database so they can real-time see, or as near to real-time as possible, what the supply status is and what things are going on, so they can start editing their supply chain to be more efficient, to make sure they've got the right number of widgets turning up at the right time at the factory. That's one app. See how many boxes I've used? And what's happened there, actually, you're seeing, is what I'm calling the chromatography of applications. Now, some of you will remember when you were at school, you did chemistry, you did a thing called chromatography, which is when you got a special piece of paper and you put that liquid on the paper, and the liquid spread out into its component parts. Remember that? That's exactly what we're doing with our apps. That big mixed up liquid was that previous big lump of server you had in your data center that ran the app and the storage and everything else. What you're now seeing is all the bits of this application are moving to the best place for them to run, the most efficient place for them to run. And it's not just the most efficient place vertically in the stack, it's also horizontally in a physical context. You know, running the stuff close to where it's being needed to actually collect the data and write it back down to the database. They're filtering on those gateways. They're not writing all of it down to SQL Server. They're taking data and writing selective data back again. Pushing stuff out to the cloud where it's needed. Our job at VMware, how do I do all of these boxes for you? We're not going to. I'm not going to provide you all of these boxes. What I'm going to provide you is an operational model for all these boxes. What I'm going to provide you is a way to build and run all of these boxes, or take control and put an operational model around boxes that are in multiple different public clouds. That's what we're going to do, and that's what we're doing today. All that stuff I talked about is all stuff that's managed by VMware today, that whole piece end-to-end, including the device in the manager's hand that they're looking at. We're looking at how do we help you achieve operational consistency across all of those pieces. That's part of our vision for this any cloud, any application, any device piece. So, moving on. My favorite slides. There's groans in the audience because I've used these 137,000 times. And if you're bored of them, how do you think I feel? But I'm sorry because this just works for me. And it's how my brain works. Okay, for those of you who've not seen this before, about 8 years ago, when we were starting to work out what the next phase for VMware was, what we were going to do was, we decided actually what we're building is kind of like RAID, but for data centers. So where you see a disk and a RAID controller, I want you to cross out the disk and replace it with pictures of data centers. These are my slides that I did, which is why that's not a data center. Okay, you can tell in here which ones are done by marketing, which ones aren't. And where it says RAID controller, cross that out and write an operating system for data centers. And that was the idea. I want to have something that sits there between applications and all the stuff underneath. Because what I want to do is I want to look at a data center as one big computer. I want to get all the networking, all the storage, all the compute in a data center, make it look like one great big pool of stuff, and then my apps turn up and just have access to bits of that pool. And then I want to spread that vision across not one data center, but multiple data centers. Now, when we first drew this, these were VMs, the things at the top. Except one of my colleagues back then, a guy called Paul Strong, who was one of the CTOs at VMware at the time, kept telling us that we should stop calling them VMs just because we're VMware, and we should call them containers, mainly because he invented zones in Solaris, so he kind of had a bit to say about it. So we kind of thought he was a bit of a mental case, but anyway, we called them containers anyway. And then a few years later, as we were building out Cloud Foundry, and then ultimately the world of Docker appeared, we suddenly went, oh, he was actually onto something there. Yeah, that's just a container. It's just different sizes, things, and where we're drawing the lines. So as we've gone along, the workloads have changed for this operating system. So now we have Kubernetes has come along as the popular thing to run on, interact with on top of this, basically containers. And now the whaley tail thing at the end, that's OpenFaaS, which is functions as a service, the leading open source project, actually, which is run by a guy, Alex Ellis, who works for VMware here in the UK, but obviously owns the project globally. Our job is to say, okay, fine, now this layer that we're pouring across all that infrastructure, the networking, the storage, the compute, That doesn't have to just deal with VMs. It has to also natively handle containers and natively support constructs like OpenFAS. So when you're seeing us do the things that we've done recently, such as launch PKS and various Kubernetes products, both on-premises and off-premises as a service in the cloud, in your data center, and the recent acquisition of Heptio, which means we now have 2 of the original 3 founders of Kubernetes and creators of Kubernetes working for VMware, along with a lot of their colleagues who really know this stuff well. What we're doing is we're trying to make sure that we can give you as native and pure a Kubernetes experience on this platform, or container experience, as we do for VMs. There shouldn't be a difference, okay? And what I'd like is that maybe in vSphere whatever, that spinning up a container is the same as spinning up a VM with no difference. It's just click, click, next, next, go. We've got that now, but how do we make containers native? Which is really quite interesting. So we're on that road for you, okay? So those of you who are playing with containers, there's a whole bunch of stuff we can do for you, and there's some sessions on that here. Those of you who haven't yet, by the time you get there, we'll be more than covered in making sure we've got everything supported for you from an operational perspective. But then, of course, just having an operating system for data centers wasn't the best thing. We renamed it the software-defined data center, or some marketing people did. And then we came up with the fact that actually it works better if we get clouds running it too. So that's the VMware Cloud Provider Program. That's VMware Cloud on AWS. And all those other options is how do we get all the other clouds to run our operating system? Thereby meaning that we've now got one layer that you can pour across the compute, networking, and storage, not only of your data centers, but also of all the public clouds that you want to play in too. So theoretically, you should be able to vMotion an application from one place to another. And you can now. You can vMotion from on-premises to someone like VMware Cloud on AWS. And Duncan's going to go through and talk in a lot more detail about some of these things later on, at the end of the day. Sorry, obviously works for Google. Sorry, we will mention Google in a minute. It's fine. So we have the ability to drag and drop across all of this stuff. That's the vision. I want to make sure that this is all, essentially abstracted for you. But then's the next bit. Can you see I do my own slides now? The next bit is Edge. This is my Edge icon. It's really cool. So Edge is very, very new to a lot of people, but it's not new to a whole bunch of you. It's just we've called something you've been doing for years Edge, okay? Because the problem that we have now is that, as I said before, there's stuff happening in remote sites that just can't happen over the cloud because the network's not fast enough. And there'll be network people in the room going, yeah, but it is. We've got 10 gig and we can do fiber and stuff. I've got latency problems that are based on the speed of light that mean I'm never going to solve that issue. Okay? You just can't do it, just purely because of the round trip time. There's decisions that need to be made in certain timescales that I just can't wait for a network connection. There's scenarios where the network is so unreliable, unstable, that I just can't wait for that. And the examples are huge. The one I always give is the difference between Alexa and Tesla. Okay? And the Alexa one is great because I have that in my house. I have Google Home as well. I turn them on and off occasionally. And so I'll sit in my kitchen and I'll say, Alexa, turn off the kitchen light, or turn on the kitchen light, depending on what time of day it is. And what actually happens in the back end, by the way, is this. Alexa takes the recording of my voice, uploads that to the cloud. It then goes through and does voice to text to work out what I said. It then goes through NLP to work out what the text meant and translate that into some computer language, which basically says kitchen light turn off. It goes, okay, well, who controls Joe's kitchen light? Well, he's got Philips Hue here that controls his lighting, so we'll hand that over to them. So we're going to send kitchen light turn off to Philips Hue. Philips Hue then look at it, who also actually run on Amazon's network, and go, okay, yeah, Joe's kitchen light, right, that's light number blah, 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 sends that down to the gateway that's in my house, which is that stupid little white thing, that actually what that's doing is that's an IP to Zigbee gateway that then changes from the IP that it's receiving of the internet to the Zigbee, where it talks to a light bulb, which then meshes to the other light bulbs, and then eventually finds my kitchen light bulb and turns it off. Magic. Right? Now, that takes about 5 or 6 seconds. maybe 3 or 4, depending on how you're doing, which is cool because that's still quicker than it takes me to get off my arse and touch the light switch, so I'm winning. And that's why Alexa is successful, okay? It's like, we have Hive heating, Alexa boosts the hot water and stuff like that happens all the time in our house, where kids now know to talk to Alexa in some interesting ways. I haven't quite dealt with all of them yet. But that's not fast enough. It's fast enough for where it is there. It's not fast enough for when I'm driving a Tesla. Now, I do have one, and I drive along, and it does autopilot, where it keeps me a safe distance from the car in front and steers within the lines. And you've probably got similar stuff in your cars with the Audi and Mitsubishi. They all have radar cruise control. And so I set the radar cruise control, and it's got numbers 1 through 7, which is the distance between me and the car in front, which actually in the UK translates to number of Audis between you and the car in front that can fit in. So what I want is when the Audi does pull in front of me in a minute on the M1 when I'm driving back down south to my next thing, I don't want the car to wait 6 seconds whilst it talks back up to the cloud, works out what the car looks like, blah, blah, blah. I want that decision to happen there. I want it to happen then, and I want it to brake instantly. That's edge. That's what I'm talking about. What actually happens, for those of you who want to know, is that's AI and ML, and this is how AI and ML pair up. What happens is there is an AI model that runs in the car on NVIDIA Drive PX2 chipset, which is now changing to another chipset. But basically, it's about 150 MacBook Pros worth of processor that sits there, executing that model, taking feeds from 8 cameras and multiple sensors, both ultrasonic and radar, around the car to draw the picture for you and work out what's going on. It's also collecting data, but it doesn't do machine learning in the car. It uploads the data overnight when it gets on Wi-Fi or on LTE back to the center. And then in the center, Tesla execute a huge ML job across all of the collected data from thousands of cars and millions of miles to then create and educate a new AI model that it then pushes back out to all the cars to execute in real time. That, by the way, is the difference between AI and ML, if you're wondering. That's really what we're talking about here. But that's edge computing. Now, what does that look like in the context of VMware? Because that's not VMware I'm talking about there. What that looks like is we're saying, okay, fine, what's the smallest I can get this software-defined data center, this operating system for data centers to run? How small can I get it? Because ultimately what you want is you want this operating system to have the same look and feel and interface whether you're doing stuff in the cloud, in a data center, or at the edge. Because what you want is you want to say to a developer, there's an API, talk to the API, and from that you can then push some VMs in here and some containers over there and a couple of containers in every branch that we've got of our retail store chain, blah, blah, blah. It just all happens. As opposed to now, where usually in most retailers, the branch team is completely separate to the core team, the data center team, and they never talk, and the branch team don't understand what containers are. They think they're plastic boxes and various other different things, and it all gets very confusing. This is about one operating model going forward. The answer to how small can we get stuff? Really quite small. Simon Richardson's here today. I don't know if he's doing a talk. You doing a talk, Simon? Are you just hanging around like a bad smell? Yeah, okay, good. So Simon Richardson leads our Edge initiatives globally for us in the Office of the CTO here as one of our principals. And you've now got down to, I think it's 2 Supermicro E200s, is it? With NVMe in there, 10 gig. There are Xeon D with 64 gig of RAM, 6 core. Correct me if I'm wrong. And you're now getting vSAN to run in it, which is quite freaky. So you get 2-node vSAN in 2 of these small boxes. So I can now run essentially an SDDC in about this space, which Simon, well, he's upgraded from gaffer taping them together to 3D printing a chassis. I preferred the gaffer tape. It was far more cost effective and quicker. But then obviously those of you who play with vSAN know, how do you run a 2-node vSAN? Because you need a witness, right? Ha-ha. Raspberry Pi. Stick a $50 Raspberry Pi on top. You can run the vSAN witness as part of that. That's where we're getting to. And now we're talking to people that want to put that, or we already have ruggedized versions of similar stuff that people are strapping to soldiers' backs, which are jumping out of aircraft and trucks to deploy command and control systems that are interoperable. We've got it going into ambulances. We've got it going into you name it as people start to look at that. We're talking to retail stores who want to use that to run their entire retail store, so run the point of sale system, run everything else on top of that. And we'll get into more detail on that later, some of what we can do. But that's the edge stuff. applications are spreading out as well as up. They're going up that stack of PaaS and FaaS, et cetera, and the bits and components that you're building in that are spreading out and out and out. A whole world of infrastructure complexity that you can now build your careers on for the next 10 to 20 years. So don't worry, it's fine. So the VMware cloud architecture is covered in this slide, which every time I put it up, I realize that white on light blue in the middle really doesn't work. But what you're looking at here is down the bottom is the multiple options you've got for running VMware-based infrastructure, Cloud Foundation as we call it. So you've got VMware Cloud Foundation itself, which is what you can run on premises. That's you running all our products on premises. Next, you've got options like VMware Cloud on AWS, one of the gold sponsors for today, or platinum sponsors, I think, whatever it's called. Did you ever think you'd have Amazon as a sponsor of a UKVMUG? Cool, isn't it? IBM Cloud for VMware, OVH, the VMware Cloud Provider Program, which they're part of, over 4,000 of those globally, all giving you options of where you can take and drag and drop your VMs, all running things like vSAN and NSX to make it easy for you to extend and match your infrastructures together. And then over here, we've got the non-VMware clouds. You could be rude and call them proprietary, but I'm not going to be. Over here, you've got AWS EC2, you've got Azure, you've got IBM Cloud, et cetera. And obviously, with these ones over here, free reign, drag and drop, move around, don't really care. Over there, a little bit more tricky, bit of conversion required, but you're going to be running bits and pieces in there too. That's where the next layer above comes in. The next layer above means that you have a management layer that gives you things like automation and security and governance and APIs and all the other lovely, sexy stuff you need to be able to manage the deployment of VMs and containers across all those things down below. Believe it or not, VMware is the world's leading cloud management vendor. But because we're virtualization guys, people don't tend to call that out. But when you look across cloud management vendors with people like IDC and Forrester, et cetera, we're number one by quite a long way because we provide, through vRealize, that huge and spread out cloud management ability. But what does it actually mean? It comes back to what I was saying earlier. What we're really focused on is consistent operations, giving you a consistent ops model across all of those things down below. And down below, through our software-defined data center that we're building, an operating system for data center, et cetera, and all the efforts we're putting into that and integrating Kubernetes and integrating open FaaS, et cetera, we're trying to give you a consistent infrastructure. Put those together in this utopian world, and you get what ultimately we're being asked for by most of our customers, an open and flexible developer experience. That's what we're building. We're getting all these pieces down below lined up to make sure that it's really easy for you to deploy new applications, use new applications, create new applications, move into the next generation for whatever it is you're doing. So what are the cool things we've announced recently and what's coming next? So obviously we've got VMware Cloud on AWS. I've talked about that. That's the entire VMware stack running on bare metal in Amazon data centers. There's multiple sessions about that here today. I encourage you to go and have a look at those. You'll probably be surprised at what we can do there for you. Recent announcements, AWS Outposts and Project Dimension. Project Dimension was the announcement we made at VMworld this year about the fact that we're working with specific hardware vendors like Lenovo and Dell to give you the ability to buy almost VMware Cloud on AWS on premises as a service. So people come and engage with VMware Cloud on AWS because essentially you get vCenter, and everything under vCenter is managed by us for you. All the stuff, vSAN, NSX, ESX, everything to do with that, the availability, patching, upgrade, you name it, is all managed by us. You just come and use it as a service and put VMs in it. Dimension is about us doing exactly the same as that with a hardware vendor, but it sits in your data center. So you don't have to manage the hardware, you don't have to manage the software, you just turn up, vCenter's there, click it in, use it. Patching, upgrades, all that kind of stuff, the concern of who's delivering that to your data center. So that's what we're working on, Project Dimension. AWS reInvent, which was, I think, last week or the week before, we announced on stage with Amazon, Andy Jassy, who leads AWS, and Pat stood on stage and announced AWS Outposts together. AWS Outposts is where you can go to Amazon, and within the next year, you'll be able to go click, 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 and Amazon deliver you AWS into your data center, running locally. Again, they provide the hardware, they manage the hardware, they deal with all the host failures, all that kind of stuff. That's their problem. And there'll be two options for that. One is EC2 native on premises, and the other one will be VMware Cloud on AWS on Amazon hardware in your data center. Now, none of these are the answer to everything, okay? And you might go, why would you want to do that? And if you don't know why you want to do that, then you probably don't want to do that. But for some people, it makes an awful lot of sense. What we're doing is we're increasing choice and giving people options on what they can do. But what that's doing more than anything else is it's underlining that multi-cloud, hybrid cloud vision, right? If the big cloud vendors like Amazon are saying, yeah, we can understand there's scenarios where you'd put some hardware on your premises to run it, then on-premises hardware still makes sense. Same as Azure Stack, and other bits of technology in that space. We also announced Amazon RDS. Amazon RDS, as you know, or hopefully some of you know, is that database layer that sits in front of a whole bunch of databases, enables you to treat them as a service. We're now allowing you to do Amazon RDS on VMware, so you can extend RDS to run on premises. It doesn't have to be an outpost, by the way. It can be on VMware Cloud Foundation. And then at the bottom is a thing called Project Magna. Project Magna is sort of, the next generation of systems management. And the next generation of systems management for us is sort of is number 2 on a 3-step journey, and that's what I want to talk to you about. Number 1 is what you have today. I deploy a monitoring system. I, as a human, kind of define this is what the system looks like, and if anything doesn't work, tell me. That's your classic systems management, okay? You might have an API on it, but it's still fairly manual in that context. Project Magna is using ML techniques and to an extent some AI techniques to do this in more of a desired state fashion, where you're saying, this is what I want it to look like, keep it like that, kind of like Kubernetes does, okay, from a container basis. So that's us saying, okay, fine, well, we're going to use ML and AI to have a look at what you think it should look like and make sure that it stays looking like that. That's Project Magna. And so you'll see that from us in the near future as we start to have things self-optimizing. Because what goes beyond that, the stage 3 as part of this, is where the system starts to tell you how it thinks you should have configured it in the first place. Which is fairly simple if you're talking about one system, but when you're talking about multiple application components across multiple locations from the cloud through the core to the edge, that's quite complicated. And do you know the really hard part from an AI perspective, when I talk about AI is not there? I have to tell the AI what I think the system should do. That's really hard. If you think about it, the knowledge that you have about running whatever system it is you run or multiple systems you run is, you know the purpose of that system. You know that system supports, job X or website Y or whatever. You also know that I don't care if that goes down on a Monday at 8 a.m., but I really care if it's starting to look a bit flaky on a Friday at 3 p.m. because of how my business runs, okay? That's where it gets interesting, That's the kind of thing we're trying to have. You're going to have difficulty from an AI perspective codifying. How do you tell a thing, okay, this is the system. This is what the system's meant to do. This is when it's important for the system to be up. Because what I then want the system to be able to do is go, actually, if that's what you want, then really you shouldn't be running 3 of those. You should be running 5 of those, and you only need 1 of those, and that you need to move over there, and that you need to do this with. That's what we're talking about, is that sort of intelligence, self-optimizing virtual infrastructure, then application infrastructure. That's the AI and ML research we're working on. But what you're going to see as we go forward is you're going to see an increase in us deploying large-scale cloud services, which you then use to manage your on-premises infrastructure. And that's where I need to ask you guys a question. Okay? So, this is new for me, but I'm going to do a real-time poll. All right? Now, I've worked very hard last night on trying to make this as easy as possible. We've even been in here and done this already. So, first thing, phones out. Make sure you've got some internet. If you haven't, there's Wi-Fi here. The Wi-Fi is free. There's no sign-up or anything. You just jump on it. I can't remember what it's called. It is called, because I'm on it here. If you can't work out which one it is, then seriously, you're in the wrong room anyway, right? NSC Wi-Fi. Okay, so jump on that. Then, I've tried to make it as easy as possible for you, okay? And we've tested this with lots of us this morning with phones. If you've got an iPhone or anything else, just hold your camera up to that. It should then give you an option to punch and go to a website. If not, go to menti.com and select the code that's up there as the one you want to put in, but that will take you straight to it if you can get that to work, all right? If you've got your flashes on, that's not going to help. Okay, so there's only 2 questions. It's not huge, all right? But I want to try this. This is where it's going to get really interesting. So the URLs and the bits are going to be on the next one as well, so don't panic if you've not quite got it working. So if I escape out of here, click on here, do that, then, oh no, not that one, crap, I've already gone wrong. That, what's Chrome? Oh, there we go, right. That's the first question. How willing are you to use SaaS-based management solutions? That's how willing are you, and this is a direct question I've got from some of our product lead teams that I've got to go on a call next week and answer. So what I'm doing actually here is I'm being really lazy, and I can go on the call and say, well, I asked all these people at the UKVMUG user group, and this is what they said, is how willing are you to use a SaaS solution to manage your on-premises infrastructure?
Joe, I guess this isn't a Microsoft. This is not scaling too well.
Don't blame me. It's not me that ran it. Keep going. Right. I get a break for a second whilst I do this. I came up with option 6 just for you, Ricky. Sorry? Can't get on the site? Oh, that'll be because of the Wi-Fi. Ah, right. Well, sorry about that. Maybe I'll leave it up a bit longer. Okay. The only thing I couldn't test earlier on this morning was 100 and something people doing it at the same time. So thank you for testing it for me. But I think amongst the people in the room, it's already starting to get some kind of thing amongst these 7 people that have answered, I think, or 13. There we go. Ricky's not answered yet because option 6 hasn't come up. So this is a challenge for us whilst you're trying to get this to work, if you can get it to work. Because we want to do this, and we've got a whole bunch of stuff like app defense and other bits and pieces and technology that are going to be operating in this model. Now, I understand, and the option 6 is for those organizations such as defense or whatever, where maybe they can't actually ever do that, and so we're always going to have options for that. It also doesn't mean that I'm going to retire vRealize in 2021, by the way. What it means is I just want to work out where the curves are and how much we're going to have to be investing in one or the other. But equally, I would be really interested in your direct feedback on this anyway. So if you feel strongly about this in one way or the other, or even don't care, email me, right? And I'm jbaguley@vmware.com. So if you can't get this to work, I'd be very interested in your responses in email as to what you think about this point. So I'm going to move on to the next one now, which is going to work just as well, hopefully, which is this question. So this is about the stuff I talked about with Outposts and Project Dimension. This is how willing are you to use vendor-managed on-premises solutions? How willing are you for us to turn up, or someone to turn up, drop an entire managed stack in your data center, and you just turn up and click and use VMs? Hey, there we go. Fantastic. It's starting to work now. 15, 18. Oh, that's better. Look at that. Actually getting some real responses. There's quite a lot of not sures there. Anyone want to say why they're not sure? Yes.
So,
Dean.
we looked at it was a price of a lock-in. That was the problem because you're paying for the hardware and Azure on top of that hardware as well. So the price was the problem.
So your problem with when you looked at Azure Stack, for example, you're getting locked into both the hardware and the software, and you maybe want to split those out or not be locked into one or the other and have flexibility around those. So flexibility in the model for what's on premises is probably, from both a hardware and a software perspective, is important to you. Okay, that's a good piece. Yes? Gotcha. So you've used Azure Stack, but you felt it was immature and not production ready, to what you're saying. Okay, fine. That's a really good one. Yeah.
Some of customers are sharing not liking the ability to be able to fix a problem themselves and being a small part of a bigger problem if there is an issue.
So again, that one is you're not happy with the fact of having, I'm repeating these so people aren't listening, is that you can't fix the box that's in your data center yourself, and if there's a massive outage, you're just a very small piece of a very, very big problem. And like it would be, for example, if Gmail went down or whatever, right? It's the same sort of thing, but that thing in there that you're running your core whatever on, because it's part of a million people doing the same thing, you're in trouble. There was another one back there, yeah.
Yeah, data sovereignty, because there's this thing about American companies having to give their data to the NSA.
So the Cloud Act.
Yeah.
Basically the Cloud Act, so it's data sovereignty. So if you've got a US company coming providing a US managed services on premises, the risk is that if you put data on that, even though it's in your data center, under the Cloud Act, that they could be asked to seize and export that to the US. Valid concern, yeah. All good ones, actually, I like that, very good. Any more?
Consistent costs.
Consistent costs. Yeah, until we get the cost models out for these things, you don't really know, do you? So yeah, I think some of it will like it because it's consistent cost. When we talk about the edge stuff, you might find those very small edge boxes, you might buy them as a managed service, so much per month or whatever. But yeah, that's really interesting. So no, thank you folks. I've got 69 answers to that. That's good. That's something great I can go back to our management with and tell them what we think or what we don't think. So thank you. I'm going to go back to the deck now as we finish up. So to finish off, we're looking as we go forward from taking the software-defined data center to being this software-defined self-driving data center. As we can put more and more intelligence into the data center to make it more and more self-operating, self-scaling, self-tuning as we can. As you start to trust the operating system more, and that's what we're going to have to ask of you is trust. Just like you trust the operating system on your laptop to make sure it saves the file in the right place and swaps the right thing in and out of memory at the right time to do what you want to do, we're going to ask you to do that on a massive scale across multiple data centers. And I understand for an organization that's maybe built a lot of skills around that and intelligence around that, handing that off is going to be a long and painful process. And that's why it's going to be painful getting people to do this. So one of the things that's also pretty cool that I want to mention before we finish up is vSphere Platinum. Now this has got some screw-ups on it. So vSphere Platinum is where we're putting App Defense along with vSphere. App Defense is, the best way for me to describe App Defense is it's the same way that you operate yourself. And what I mean by that is, you got up this morning and you went, yeah, I feel all right. You didn't scan yourself for 150,000 known viruses. Okay? To be honest, with the bit of the cold that I picked up from the two people I went to a meeting with on Monday, I wish I could scan myself for them because I'm cursing them now. But App Defense is about doing exactly that. Learning what's normal across our experience of 50 million VMs, plus the experience of what you're doing on premises in your environment. And learning what's normal is really important, because what's normal could change. And it needs to be trained on what you're doing too. So the example I always give is you go into the doctor, and the doctor sort of goes, oh my God, your nose is really big and red. And you go, yeah, thanks very much. It's always been like that. It's my arm that hurts. Okay? And that's when you go and look at that machine and, counter X is at 27. You're like, oh my God, counter X is at 27. Yet the woman who runs that machine comes and tells you that it's always at 27. She's used to that. It's this thing over here that's the problem right now. It's the IOs or whatever it is, right? So with this allows us to put a lot more intelligence. Because we're in that Goldilocks zone, as we've always called it in the hypervisor, where we're seeing everything to do with the machine. It gives us immense power. Because I'm seeing every single thing that goes on that machine. Writes to cache, writes to memory, processor writes, everything. So the insights that I get are huge. Put that together with NSX, and you get adaptive microsegmentation. I get the ability to do some really cool things, like shut down ports, quarantine things, put firewalls around stuff instantaneously, but also spot things like, hang on a second, it's talking to that port over there on that machine that it never does, and this machine's talking to the internet, et cetera, et cetera. So that's an example, again, of how we're starting to bring AI and ML into the system. We're starting to make things a little bit more intelligent, a little bit more aware. I'm not going to use the word self-aware, a little bit more aware. So you've got a system now that learns the intended behavior of the application and can lock the computer network using knowledge of what's going on in the application.
Is it dangerous, John?
Oh, it's really dangerous. Yeah. So the question is, isn't it dangerous? The answer is, yeah, there's a possibility if you don't configure any system correctly, you could cause some real problems, right? So it's down to very careful adjustment and setup of the system, yes. So yeah, you could have it shutting stuff down that you don't want to, yeah, if you configured it incorrectly. But that's where, we're bringing experience to the fore in that one and helping you guys do that. Adapts to continuous change in the application and shrinks the attack surface. Last thing, new virtualization frontiers. Couple of things we announced. One of them was ESXi on 64-bit ARM, which Simon mentioned earlier on. ESXi on Raspberry Pi. We announced it, showed it on stage. We're still developing it. I'm hoping I wanted to, and this is what I really wanted to do. What I wanted to do at VMworld Barcelona was I wanted to do the Oprah Winfrey moment, right? Where everyone reached under their chair and pulled out a Raspberry Pi in the audience. But I was told that 10,000 Raspberry Pis was, one, quite expensive, and two, the code wasn't ready yet. So when the code's ready, and it'll be ready when it's ready, we will get that code out to you to play with and see what you guys can do with it. But we've already got some excited people doing some interesting things with it and playing as we go. So, sticking two of them together, putting them on top of a wind turbine to make a fault tolerance monitoring pair, for example, for less than $100. Those kind of things is where it could get really quite cool. And one last thing I want to mention as we finish up. Who here's heard of VeloCloud? Okay, those of you that haven't, go and have a look. Right? Because VeloCloud is SD-WAN. And again, what's SD-WAN? I don't care, okay? SD-WAN is essentially turning the way that you manage WAN to the same way that your broadband provider manages broadband, but way better, okay? Because no one likes their broadband provider. But what it means is that you get the ability for your environment to send out a box that's FedEx supported, as I call it. Like, it really doesn't need anyone to do it. You plug it in, there's sockets on the back marked up, MPLS, IP, 3G, 4G with USB, and then you manage your entire WAN centrally. You can do quality of service, you could have multi-routing across multiple different route paths. It's amazing, okay? And you can push all the NSX intelligence out to that too. Remember I talked earlier on about putting two things together to make something cool and new? Remember I've been talking about getting that two boxes, the little boxes with the Raspberry Pi on top and making that edge box? Imagine if I ran this functionality as a VM in it. And now I've got SD-WAN running in software in a small edge box that you can deploy anywhere that manages quality of service, multipath routing, security, everything. That's the future I'm trying to get you guys to think about. So as we move forward in the next 20 years of VMware. Now, here's the interesting one, right? No one can predict 20 years in the future. If they could, it would be amazing, right? I certainly can't. If I could, I wouldn't be here. I'd be on my boat in the moment in the middle of the Mediterranean, which I don't own, by the way, because I couldn't predict the future. And it's huge, this boat. I mean, it's massive, right? It's got 2 helicopter pads, one at the front and one at the back, okay? Because of all the money I made investing in certain shares in 1999, which didn't happen, okay? If a software company gives you a roadmap for a product that's longer than 2 years, they're probably lying. But what I can tell you is, for me, it's about spotting where things are going and understanding the major trends. I was always told, if you take a picture of a river, that's what the river looked like then, that moment. And the picture's now invalid, because before you took that picture, the river looked different. And after you took that picture, the river changed again. For me, it's not about the picture of the river. It's about looking at it, understanding where it's going, what it's doing, what's in it, how big is it, how fast is it, where are people going on that river. And hopefully today I've given you a bit of an insight as we talk about how applications are changing, expanding, the chromatography of those applications as they spread both vertically in the stack and horizontally in your infrastructure. At the same time, as we start to look at how technology pushes closer and closer to the edge, the new types of workloads around AI and ML as they deploy themselves both intelligently in the data center, but also closer and closer to the edge too, are going to utterly change the services, the applications that we build, provide, support, and operate. And at VMware, my job is to make sure that by the time you guys are trying to do that, we're already there with the right stuff to make it as easy as possible for you. So thank you very much for listening to me. It's the first time I've ever presented in a planetarium, which is really quite cool. And it's been very enjoyable being the warm-up act for Duncan Epping. And in fact, to be fair, I've actually been the warm-up act for the next person who's in here, who's Vern Bolnius. So thank you very much and enjoy the rest of your day. Cheers.